going to look at lesson 9B, which is talking about measures of dispersion, especially standard deviation and z-scores. So, a standard deviation is basically the measure of how much the values in a data set vary. So, represented by a Greek letter sigma. But it's a lowercase sigma, unlike our summation, which is an uppercase sigma. So we're looking at sort of like that. I usually refer to it as like an O with a mullet. To do it by hand, which we will do a few of, just so you can see the process, and then I'll show you some other strategies that are less time consuming. It's kind of a long process, but none of the steps are hard. You find the mean, then you find the difference between each value and the mean. You square those differences, then you take the average of these squares and then take the square root of that average. Okay? Again, not difficult steps, but there are a lot of it. Now, it's perfect. You'll notice today in the ones we do by hand, we're only going to work with data sets that only have a few values. But if we're looking at data sets with anything more than 10, you're going to want to use another strategy. You're not going to want to find the standard deviation by hand of something with 50 values. That's crazy. We have tools to do those for us. I did want you to do a few by hand though, just to showcase that process first. So if the standard deviation is low, then our data is more clustered together. If the standard deviation is high, then you're going to see more variance and the data is more spread apart. So variance is the average of the squared differences from the mean. It's basically all the same steps except not taking the square root. It's like right before that last step, okay, or squaring the standard deviation. It's denoted with either sigma squared, makes sense because it's standard deviation squared, or sometimes you see it as var of x. Instead of these being called measures of central tendency, they're really called measures of dispersion because it's describing how the data is scattered rather than where is it centered at. So standard deviation, variance, range, interquartile range are all measures of dispersion. I believe I mentioned that in our last video. So here we have, I'm going to call them test scores. Okay, I have 5 test scores and I want to find the standard deviation. We're going to do it by hand a few times. So the first thing I want to do is find the average. That's what this piece here is, that x bar. That's the mean or the average. So I'm going to add them all up and divide by 5. So my average comes out as 91. I don't really need to write it in all the rows, but I'm going to. Now, we want to find each of those values minus that 91. So 78.2 minus 91 is negative 12.8. 90.5. So this is basically describing how far away from the mean are each of these values. Are they close to the mean or are they far away from the mean? The smaller the number, the closer they are to the mean. And okay. Notice here only 2 of the values are negative and 3 of the values are positive. That's because 2 values are below the mean and 3 values are above the mean. However, the moment when I square them, the negatives aren't going to matter again because it's still talking about how far away it is from the mean. So this is just taking the previous column and squaring it. And one more. Okay, so if I look back at my steps for a minute, it said I needed to find the mean. We did that. We found the difference. We did that. We squared the differences. Now we're going to take the average of these squares. So I have 5 numbers here, and I'm going to add them. So when I add them up, it's 234.04, and then I'm going to divide that by 5. That gives us 46.808, and then I'm going to take the square. So this would be my variance. And when I take the square root of that, I get 6.841. So that's what our standard deviation is. Okay. So you and your friends have just measured the heights of your dogs because you're in quarantine, and what else is there to do? In millimeters, because we're going to be really precise with this because, you know, that's how it is. The heights at the shoulders are 600 millimeters, 470 millimeters, 170 millimeters, 430 millimeters, and 300 millimeters. Find the standard deviation. Pause the video and try this one on your own. Okay, so first thing I want to do is I'm going to make one of those little charts because I like them. You do not have to do them as charts. I just like them because I like that it's nice and organized. And one more row. So I'm going to find the average. The mean is 394. 394 for all of them, so I'm just going to do that. And then I'm going to do the value minus the mean. 6. -224. -36. And -94. Okay, again, you see a mix of positive and negatives on all of these. So now I'm going to take all of these values and square them. You could see how this, if I wanted to do a lot of numbers or anything, if if the average didn't come out as a nice number, it could be kind of messy on a lot of these things. Okay, now this is x minus x bar squared in case we cared. Now I need to find the average of these. It's 108,520 divided by there are 1, 2, 3, 4, 5. 5 in this entire population. We're dealing with this as a population. That's going to be important in a little bit. So that's 21704. That's my variance. And last but not least, I do the square root of that, and I get sigma is 147.323. I tend to do my standard deviations to 3 decimal places. So you can actually find this on the calculator as well. I mentioned that, okay? So pull out our calculator. Oh, look, the data's in L1. So if you haven't already, go to Stat, Edit, and place that data in L1. Clear out any other lists that you might have so you don't have any excess values messing up our standard deviation. A reminder, if you needed to delete some values, let's just throw 96 in there. If you needed to delete values, you can delete them individually one at a time like that by hitting delete on the value, or you can head up to L1 or L2 or L3 and just hit clear on it. Okay, so now I'm going to do stat over to calc, and I'm going to be back in that one variable statistics. We looked at this the other day. One variable statistics. There's that X bar. We knew it was 394 from doing it by hand. And, ready? You can even see right there. There's our standard deviation. Just what we got. I rounded. The 2 I bumped up because of the 7. So there is standard deviation, and that was significantly quicker than doing it by hand. But it is good to understand what the calculator is doing when you're working with these. Okay, so next. If I wanted to find the variance also, because notice it doesn't give me variance, if I scroll down you just get more of that 5-number summary, I can just take this decimal that we have there and square it to get to variance if I needed to know that. You want to know both methods because depending on and I'm actually going to highlight a third method at the end, but depending on what you're working with, you need to have more than one tool available to you. Okay? All right, so example 3. The number of points that Darden scored in each of 11 basketball games is listed below. Within how many standard deviations do the values fall? Okay, so first thing I want to do is find the standard deviation. So I'm going to go to edit and I'm going to put in the new data. 8, 12, 13. All right. Nice feature here when it says L1, you can see this is L1 of 11. So that is the 11th term plugged in, which means I've typed in all 11 of my basketball games. I'm going to do stat, calc, one variable statistics, boom. I'm just going to snag the picture of that. See, he keeps double bringing it in. Whatever, doesn't really matter. So from my mean, that's going to be, I'm just going to make a number line for a moment. From my mean of 9.636, and I also want to identify the lowest, which would be 5, and the highest. What was his best game? I think his best game's 13. Yeah, 13. So, and we also have this standard deviation of 2.422. So, one standard deviation above that mean, okay, would be 9.636 plus 2.422, which would be 12.058. That does not encompass all of it because he had one game where he scored 13 points. So I add another standard deviation above. This is positive. These are one standard deviation above. That's why I wrote a plus. Okay. And that would be 14.48. Now on the flip side, if I look at standard deviations below, oops, if I look at standard deviations below, minus one standard deviation would drop us down to 7.214. And then when we subtract another standard deviation, I'm going to be at 4.792. Now his lowest score of 5 would be like right here, and his highest score of 13 would be right around here. Okay, now the big debate. Within how many standard deviations do all the values fall? We would say within 2, because it's 2 above or 2 below. So that 2, we don't need to say 4 because within 2 is talking about 2 either above or below. All right, so a z-score. It's the number of standard deviations that a value is from the mean. Okay, so our z-score is just calculated by, if you're using symbols, x minus x bar over sigma, or really just the value minus the mean over the standard deviation. So if I was looking at this 5 for a minute here, its z-score would be 5 minus 9.636 over that 2.422. Now, 5 minus 9.636 over 2.422 is negative 1.914. So this previous question was saying only answering within whole standard deviations. Within how many standard deviations does the data fall? And so this has a z-score of negative 1.914. So that's falling within 2 standard deviations. The z-score is not larger than negative 2. So, or less than negative 2, I guess. Okay. So find the z-score for Darden's score of 10 points. So we just did that. So for 5. So pause for a second, try it for 10. Okay, so for 10, it should be 10 minus 9.636 over that 2.422. Which is a positive 0.0150. So I'm just going to leave that piece off. So this has a positive z-score, and that's indicating that it is above the mean. The previous one had a negative z-score, indicating it was below the mean. So Sam has 20 rose bushes in his garden. The number of flowers on each bush is indicated in there. Work out the standard deviation. I do not want you to do it by hand, so you use a calculator. Okay, so pause the video, find the standard deviation. So the standard deviation on this one is 2.983. So I've made a big deal about this, but there's a difference between working with the entire population. So this was his entire garden, all 20 rose bushes. He didn't have more than 20 rose bushes, and only a sample of the population. Sample would be is if he selected 20 of the bushes in his garden of 100 and tried to extrapolate that data to a larger set. Okay, so all the ones we've been doing is everything. So this was all of his rose bushes, all of the 11 games, all of you and your friends' dogs, and all 5 people who took a test. Now, where this would be different is if I said these were select 5 samples from our class of 22, and that would indicate it was a sample. How you have to do it with a sample is different. So if we are calculating the sample standard deviation, then what we'll do is when we do that step of dividing to find the mean, the second time, you divide by n minus 1, one less than the number of data values. Okay, so I'll go back up to this one for a second. Okay, so here, this was a 5 if it was the entire population. The difference here, if I knew it was a sample, it would have been over n minus 1. So instead of over 5, I would have it over 4. So 234 over 4 gives me 58.51, and then I square root that. Now, 7.649. Now, if you notice, so I'm going to call that S, because that's standard deviation of a sample. You notice the sample standard deviation is higher than the entire population, and that's to account for the other values outside of the sample we selected could have a wider spread than what we're seeing. So that's what the difference between standard deviation of the entire population and standard deviation of a sample. And you'll be able to tell by the wording of the question whether you're working with the entire population or if you're working with a sample of the class or a sample of the population. So here, a selection of test scores. So right there, that selection. We're just picking some of them from our class are given there. Find the standard deviation for this sample population. So pause the video and try this one. So let's see. First things first, we want the average. So 85, 87, 71, 93, and 95. 86.2. So my X bar is 86.2. 5, 7. So 85 minus 2 is negative 1.2. Negative 15.2. 6.8. Okay. So then I'm going to square each of these. 4. And 8.8. All right, so now I'm going to kind of take the average. So I'm going to tally up all of these. Okay, and so it sums to 356. Sorry, 0.8. Now instead of dividing by 1, 2, 3, 4, 5 values, I'm going to divide by 4 because and the reason why is that it's a selection and it's a sample. They literally said in the problem, sample population, but a selection was enough information to tell me that I want to do a sample standard deviation. I divide by 4, that's 89.2, and then square root of that is 9.445. Okay, so if I had my calculator, and you can see I found the in there. Stat edit, I type in that data right there, and we're going to go back to that stat calc one variable statistics, just like we've been working with. And you can see the standard deviation of the entire sample is 8.447, but the sample one is given right above it. There's our sample standard deviation. So the calculator will give you both standard deviation of the entire population as that sigma one and of a sample. So it's going to be important that you read the question and determine which one you need to be doing. So I also wanted to show how to do this in a spreadsheet program. So you could do this in Excel. You could also do it in Google Sheets. So if in Google Sheets, I'm going to take the dogs from earlier. So because that picture is just adorable. So you and your friends have just measured the heights of your dogs. Okay, we had calculated the standard deviation to be 147.323. We already did this problem, but I'm going to just do it in the spreadsheet as well. So you can see my spreadsheet. I have my heights of my dogs. Okay. Next, I'm going to go to an open cell. I'm just going right underneath it and equal and start with stand. And then you get a couple of different options. So if you type in just standard deviation, Excel and Google Sheets both default to of a sample, not of the whole population. So if you choose one of these, that stdev.s, that's sample population, sample, whereas this is the entire population. So in your normal standard deviation, is automatically going to be of a sample because they're assuming most of the time you do not have every single person that that criterion meets against. So standard deviation of the sample. And then I just select these. You could also type in A2 through A6. Notice it's got a colon between them. And so that's the sample one. And if, oh, that's all right, I'll just do it in for. So standard deviation of the entire population of those. And there's the one we had. So this was of a sample, and this was entire population. So again, the calculator and spreadsheets and lots of other tools can calculate standard deviation for us. So most of the time people don't do it by hand, but we did see a few just because it's important to see where the math is coming from on things. And this concludes today's lesson on standard deviation and variance.